Hi students, this is Neeraj Bansal and you are watching my YouTube channel. Today we are going to do limits and derivatives, right? So first of all, we need to understand what are limits. So limits and derivatives. Calculus is most important part in AAHL, right? So first we need to understand what is a limit, let's say, right? So what do you think is a limit? Let's say this is the graph which I have, and this is 0.24. This means when my x is 2, my y is 4, right? But what if when I'm saying I'm very close to 2, but I'm not 2? We'll give you another example. Let's say this point is A. That means my x is A and my y is capital A. So I'm saying one thing is I'm saying x is equal to A. But one thing is I'm saying x approaches A. It is read as x approaches A or tends to A. So as x approaches A, fx tends to A. This A I can approach from the left hand side or I can approach from the right hand side. This is the negative side and this is the positive. So how do I write it? This is read as limit fx as x tends to A is equal to, this is what it means. Sometimes you will see the notation like this, limit fx as x tends to A positive and limit fx x tends to A negative. This means that x tends to A from the positive side. This is not A is positive and this is x tends to A from negative side, right? So how do we use the limit? Let's consider a function x squared plus 5x over x. So I can say as x tends to 0, fx tends to 0 by 0, which has no meaning or undefined, right? But what if I do limit x squared plus 5x over x as x tends to 0? I want to find this. So in this case, it becomes 0 over 0, which has no meaning. But what I can do is limit x tends to 0, x times x plus 5 over x. X cancels x. Now I'm left with limit x tends to 0, x plus 5. So as x tends to 0, x plus 5 tends to 5. So my limit x tends to 0, x squared plus 5x over x is 5. I hope this is clear. Now we'll do a couple of questions how to find the limits, then you will understand. So let's come to this. So let's talk about this. Limit x squared x tends to, so as x tends to 2, x squared tends to 4. Therefore limit x tends to 2, x square is equal to 4. Let's do next question. Limit x tends to 0, x squared plus 3x by x So limit x tends to 0, x times x plus 3 by x, x cancels x, so this will give me limit x tends to 0, x plus 3. So as x tends to 0, x plus 3 tends to 3. Therefore, limit x tends to 0, x squared plus 3x by x is equal. I hope this is clear. What is the advantage of it? We will do subsequently, right? Then next comes, so in this case, what is happening? Let's say, let's take this. We are saying, let's solve this. So limit x tends to 1, 1 over x. So as x tends to 1, 1 over x tends to 1. Therefore, limit x tends to 1, 1 by x is equal to 1. Here, there are two ways of solving it. One, I can solve it directly with this thing also, but we can plot the graph as well. So first I'll solve it normally. So I'll say as x tends to 0, 1 over x tends to 1 over 0, which is nothing but infinity, right? So you will not write limit x tends to 0, 1 over x is equal to infinity. This is wrong, because infinity in itself is nothing. It means it is a very large number. We don't know what is the number. So what you will write, limit x tends to 0, 1 over x does not exist. You will write like this. You will never write like this. Got it? Then there is another important thing. Limit exists only if limit fx x tends to a from positive side is equal to limit fx x tends to a from negative side. I'll just make this graph and then I'll give you an example. Although the limit does not exist in this case, this is my graph. So if I take this point, that means if I put limit 1 over x, x tends to 0. So this x is equal to 0, I can reach from here and from here also. So what I can write is limit x tends to 0 from positive side, from positive side. So as x tends to 0 from positive side, 1 by x tends to positive infinity. As x tends to 0 from negative side, 1 over x tends to negative infinity. Although in this case, what is happening, both the sides are, anyhow, the limits are different from the positive and the negative side, but at the same time, this is infinity, so it doesn't make any sense. That means the limit does not exist, right? So let's do some other question. Now, again, another important thing is, what happens as x tends to infinity? Means x tends to infinity means x is a very large value. In this case, you have to see which is my highest power of x and divide both numerator and denominator by the same, and then we'll get the answer. I'll just do it, then you will understand. So what I am going to do is limit x tends to infinity to x. I'm dividing everything by x, plus 3 by x, x over x minus 4 over x. So this becomes limit x tends to infinity. So 2 plus 3 by x over 1 minus 4 by x. So anything over infinity is 0. As x tends to infinity, 3 over x tends to 0 and minus 4 over x tends to. Therefore, limit 2x plus 3 over x minus 4 as x tends to infinity is equal to, got it? Once I'll do another question, then you run. Let's do this. Limit x tends to infinity, x squared minus 3x plus 2 over 1 minus x squared, right? So in this case, what you need to do is, now the highest power is squared. I will divide everything with squared. So limit x tends to infinity, x squared by x squared minus 3x by x squared plus 2 by x squared by 1 over x squared minus x squared over x squared. So let's see what I'm getting. So limit x tends to infinity. So x squared by x squared is 1 minus 3 by x plus 2 by x squared divide 1 by x squared minus 1. So as x tends to infinity, 3 by x tends to 0 and 2 by x squared tends to 0 and 1 by x squared tends to 0. Therefore, limit x tends to infinity what was my question? X squared minus 3x plus 2, x squared minus 3x plus 2 over 1 minus x squared is equal to what? Negative 1. So this is my, hope this is clear. Now we'll talk about trigonometric limits. So when we are talking about trigonometric limits, sine limit theta tends to 0, sine theta over theta is equal to 1. This you have to remember. This is also given in the form. So let's do one question on this. How do we use it? Then you will understand. So let us take this question. Let's take this. So it is saying find, sorry, then limit of theta tends to 0, sine 3 theta by theta. Now in this case, what you can do, multiplying both sides by 3. So this becomes 3 limit theta tends to 0 sine 3 theta by 3 theta, right? This becomes 3 times 1, which is, so this is how you use the trigonometric limits. Then you can use graph also to find the limit. As you can see this question, right? So this is my question. Let's solve it and you'll understand. So why I have done this, I want to show you this graph. So limit 3 minus e raised to the power minus x as x tends to negative infinity. This means what? This means as my x, I'm saying when x tends to negative infinity, that means a very large negative number. So if I'll move, this is my graph. So as I'll move and x becomes a very large number, y also becomes a very large number, right? So as x tends to negative infinity, I'll write it as x tends to negative infinity, p minus e raised to the power minus x tends to be negative infinity. So therefore limit x tends to negative infinity, p minus e minus x does not exist. Got it? But what happens if x tends to positive infinity? Let's see. So limit x tends to infinity, p minus e raised to the minus x as x tends to infinity minus e minus infinity, e minus of x tends to 0, tends to 3, right? Therefore limit x tends to infinity, e minus x is right. Then we need to understand what are continuous functions. Let's see if I plot a graph something like this. I can plot this graph without raising the pen from the paper. Got it? But let's say if I have a graph something like this. So what is happening? If I make the graph, I'm making like this, and then my hand is broken, and then I make like this. So there is a break. And in this case, the function becomes discontinuous. Discontinuous. Got it? So now there are 3 types of discontinuity. Basically 2 types of discontinuity, you can say. First is jump, or rather fall. Second is jump, and third is break. What is fall, jump, and break? And I'll give you the example. Let's say if I have a function like this thing is called whole. And let's say I have a function something like this. This is called jump, because at this point there is a jump. I'll give an example, you'll understand. And what is a break? Let's take an example of a rational. So here is a break. This is an asymptote. We have already done in the rational function. So then you can classify these two types of discontinuities. Two types of discontinuities are essential discontinuities What are essential discontinuities? The jump and break. That means these continuities cannot be removed. But then I have non-essential discontinuity. Which is 4. Right? So I'll give you an example of essential and non-essential discontinuities, and then we'll be able. Let's say first I'll talk about non-essential. These continuities can be removed. Like let's say if I have a function x squared plus 5x by x, right? But what will happen at x is equal to 0? This will become 0 over 0, which is undefined. But at 0, I can define another function, which is x times x plus 5 over x. X cancels x, so this is x plus 5. So I can say at x is equal to 0, we can define another function x plus 5, then the function becomes continuous. Then the discontinuity is removed. Got my point? So we can say non-essential discontinuity can be removed. But what about the essential discontinuity? There are two types of essential discontinuities. Jump. So let's say if I'm saying fx is equal to 1 when x is equal to, or rather x is greater than equal to 2, and fx is equal to minus 1 when x is equal to, x is less than 2. Basically these are called piecewise functions. Piecewise function means up to a certain domain they behave in a some manner, and after that domain they behave in a different manner. So if I plot the graph, it will look something like this. So let's say this is my 2, right? So when x is greater than equal to 2, y is equal to 1. So this is included. So I'll write this is my 1, this is my negative 1, and this is my 2. So this is included. So the graph will look something like this. And for less than 2, will look something like. So basically there is a jump which you cannot remove. So this is called non-essential discontinuity, or rather essential discontinuity, I'm sorry. Then let's talk about the break. Break is, I have already given you an example. Let's take the example of a rational function. The graph looks something like this. So if this is my graph, right? So when you have a graph like this, at this point, at x is equal to 0, right? At x is equal to 0, there is break, which you cannot remove. Alright. I hope this lecture is clear to you. So we are done with limits. In the upcoming video, we'll talk about the derivative from the first principle, and then subsequently we'll do differentiation. Got it? So in the meantime, you can practice more questions and just my video 1 or 2 times. If you find something difficult, or you can contact me at the number given below, and pretty soon I'll be going live, maybe from the next week. Then it will be better, I think. Yes. So please subscribe my channel.